Is this particular infinite sum a convergent series? Short, sweet, good question. What do we see here? So we're adding from 1 up to infinity. 3n plus 2 to the n over 5 to the n plus cosn. In that exponent there, that little exponent, there he is. Okay. So, what do we see here? Well, my eyes are drawn to the power n up here, as well as the power n here. I don't like the cosine n, but I'm willing to sort of forgive that and say, well, even with all these powers of n, all these something or other to the n, this makes me think root test. It is important to understand, just because that's my first instinct does not mean that this is a root test question. Okay? I'm pretty sure it is, but that's mostly just from experience of doing so many of these. It is entirely possible, and something that you occasionally need to come to terms with, that the first instinct that you have might be wrong. You might be missing something. That usually just means you need a little more practice, but it happens to everyone. No one knows how to do all these sequences and series things. No one knows how to do integrations. No one does everything perfect right off the top of their head. Sometimes you got to play around. Sometimes you got to say, I think this is a root test, but then, boom, it was actually nth term test all along, or it was a limit comparison, or something. Right? But just trying to explain my reasoning, the whatevers to the n make me think root test. So let's try root test. If that blows up in my face, that's okay. That happens. All we got to do, pick ourselves up, dust ourselves off, and try again. That's how it works. So let's try, or let's use root test. Okay, let's try that. So we're calculating the row, limit as n tends to infinity, nth root. So what do we got? 3n plus 2 to the n, all over 5 to the n plus cos n. So the nth root's going to come along, and it's going to make some of this nice and easy. So the nth root will cancel the n on top. So here's what I'm going to do. I'm going to do it slowly because I want you to be able to follow along. 3n plus 2 to the n. So we're going to split the nth root. And instead of writing nth root on the bottom, I'm going to write to the 1 over n. Okay, because of that cosine in there, I've got to be a little careful about how this works. Now up on top, nth root and n, yeah, cancel out. Great, fantastic, love it. Right, could not be happier. So 3n plus 2 up on top. On the bottom, when we bring the 1nth in, you get 5 to the n plus cos n all over n. But the n's cancel out a little bit, and you're left with 1 plus cos n over n. I get 1 plus cos n over n. Okay? So this is much simpler. Can we calculate this limit? Well, let's look at each individual piece. As n gets really, really big, 3n gets even bigger, and adding on 2, I mean, it barely does anything, but it gets bigger and bigger and bigger. So the top is getting bigger and bigger. Symbolically, we might write infinity. Okay? What's the bottom doing? Well, the bottom is 5 to the power 1, so that's just 5. And then we've also got this little cosine over n. So let's look at this piece first. Cos n, now cosine is between -1 and 1. Dividing by n gets you something between 1 over n and -1 over n. Both of those, as n gets really big, we know go to 0, so this middle guy, he goes to 0. So this is sort of a quick little squeeze theorem if I wanted to write it out, if I wanted to explain it to someone, but really that's just what's going on in my head. N is growing way bigger, cosine is bounded, so it's going to 0. So the bottom is basically going to 5 to the 1 plus 0. So it's basically looking like 5 eventually. So the top is getting bigger and bigger and bigger, like I think millions, billions, trillions, and we're dividing them by basically 5 each time. So what's happening? Well, in the long run, this limit is going to grow and grow and grow, and symbolically, we would say it just tends to infinity. Now, it's okay. Root test, it allows for your row to symbolically have a value of infinity. That is perfectly fine. We treat infinity, even though it's not a number, but we still write row equals infinity. So for some people, it's a little confusing. But we treat infinity like a number that's bigger than 1 when it comes to writing out the test. Or some people use a separate exception, that if row is bigger than 1 or symbolically is infinity. But in either case, this allows us to conclude that our particular sum, so 5 to the n plus cos n here, and 3n plus 2 to the n. So this particular sum diverges by our good friend, the root test. And we're all done.